Hello, my name is Jonathan Apostle, and this is my second lab submission for Physics 2212. Since I have already documented my experimental data in Lab 1, I will just use the same data for this report. And I'm going to be focusing on improving the computational model, and this is going to change because I will be looking at how to distribute the charge along the tape. Unlike in Lab 1, where the charge was modeled as concentrated at a single point in the center of the tape, I now need to evenly distribute the charge along the entire length of the tape in the computational model. Additionally, I will be utilizing this provided starter code, which I'm just going to paste in GlowScript to begin my model. I'll modify the code to calculate the electric forces exerted by a distributed charge on the tape. Looking at the fundamental models and concepts, the electric field superposition is critical in the distributed charge model because it allows to explain how the electric fields produced by different parts of the tape combine together to create the overall electric field. Again, the total electric field at any point is the vector sum of the electric fields produced by each charge individually. The superposition allows me to account for the fact that the electric field at any point near the floating tape results from the combination of fields from all parts of the other tape. And this is something that we didn't take into account at the very start of the lab. While I'm still in the introduction, I wanted to provide a brief preview of the results. And this was that the line model, the one done in part 2, is going to be more accurate than the point charge model, the one done in part 1, because it more accurately reflects the nature of the charge within the tape. Now, looking at the key formulas, first I can find the electric field, and this is going to describe the point charge model. This is from part 1 of the lab. It is used to understand the field created by the tapes and how it affects their interaction. Additionally, the gravitational force is very important, especially in the floating tape experiment, and similarly, Newton's second law correlates directly to this. But one of the key ones that we're going to be looking at now is the electric potential energy. And this energy relates to the potential energy between the charges. And this is because in part 2, it helps to understand the energy changes when comparing the point charge and line charge models and how the distribution of charge will affect that energy. Just to be clear, I was going to explain one more time the use for these formulas. And this is because in part 1, the electric potential energy can be utilized to find the electrical energy that would be present when looking at multiple point charges. In other words, the charge tape is multiple point charges instead of just one. This was something that wasn't initially taken into account. As previously discussed, the initial conditions and experiment do not change. This was the same from Lab 1. And the measurements that I found was the mass of the tape was about 2 times 10 to the negative 4th grams, and the length of the tape was 0.2 meters, and the width of the tape was 0.02 meters. Similarly, the system and surroundings, the system will be tape B, and the surroundings will be tape A and Earth. We take Earth into account because of gravity, obviously. And again, this is the same exact as the previous lab. Alright, now looking at the GlowScript code, what did I change? So in the original approach, we used the point charge model, so the entire charge is considered to be concentrated at a single point, and therefore this is going to be utilized to calculate the force. However, in this there were a few quick changes. So for starters, now we're seeing it as our line of charges. And then what that means is that the code would then model it as a collection of point charges distributed along a line, and this will approximate a continuous charge distribution more accurately than a single point charge will. Obviously, we're doing this for improved realism because naturally all of the charge is not going to be situated at one point on the piece of tape. And additionally, it's going to help out with the visualization as well because the electric field and force calculations are adjusted, so therefore the charge is going to be distributed in an even nature. So this is what it's going to look like when it's run. Now, looking at the results, you probably wondered, wow, why is the electric force and the gravitational force so different? And yes, these are correct. The magnitude of the electric force was 2.01 times 10 to the negative 3 newtons, and the magnitude of the gravitational force was 1.96 times 10 to the negative 3 newtons. However, there's differences in this. And these differences come from the fact that I probably had some human error when I was measuring the distance between the tapes. Now looking at the conclusion and discussion, taking into account the magnitude of the electric force and the gravitational force, we can see that this model is way more accurate in describing the distribution of charge along the piece of tape. Yes, there are differences. However, as I previously stated, these can most likely be chalked up to human error. Now looking at the what if and why questions, and these two kind of build off each other. For starters, what if we had modeled the tapes as a single point charge? As we previously said, it's going to be way less accurate. This is because you're not taking into account that the electric field is evenly distributed across the body. Next, compare the estimated value that we got with the one for the point charge model. And this is interesting, and I had to think about this a little bit, but I believe that if we looked at the point charge model, then it's going to be a little bit lower. And this is because we're calculating there's this potential energy that's present between all of the point charges that's going to be present within the second model and not the first one. So just to summarize, I started with the introduction, previewing the results, seeing the models and principles, the main results, the initial conditions, the principles of physics, the assumptions, and then looking at the GlowScript code, potential sources of error, and answered the what if and why questions. And just to be clear, the purpose of this lab was to show that the line charge model is way more accurate than the point charge model, and it's going to reflect the true nature of tape and the distribution of charge.